Okay. Can you see the whiteboard?
Yes, yeah.
Okay, all right. So, first topic is differentiation. Let's start it. First of all, let us understand what it means. A function y of fx can be defined as y is equal to fx. We say this y is a
Okay.
function of x. That very well because so we have learned already in 12th standard. And I'm telling you with comparison. For example, if you have, very well, area of circle, we have pi r square. So obviously this area depends on r. Similarly, this value of y depends on x. So
X.
we say
Okay.
this is function of x. So when we make a change, any change in x, obviously we'll get a change, respective change in y. So
Yeah.
differentiation is rate of change of y with respect to x. Okay.
Okay.
So we have lots of formulas here. So I'm telling you along with each example of each. And symbol of differentiation is with respect to x, we denote by d over dx of y or simply dy over dx. This is a first order. I'm telling you later,
Okay.
higher order also because we have
Yeah.
a differential equation. That is why I'll tell you. And they denote by f dash x also or by using symbol dy means all symbols of derivative I'm telling you. Sometimes they use
Okay.
this symbol y1 or y dash. Okay. So
Okay.
now let us learn its formulas one by one along with example. So first formula, differentiation of constant, because differentiation is about rate of change and here we
Yeah.
have constant means there is no change, that is why differentiation of constant is zero.
Okay.
You have done these all formulas already, but now we are going to just brush up them, right? You want
Yeah.
that?
Yeah.
Okay,
Yeah.
all right.
Exactly.
Okay. So differentiation of x with respect to x one, and similarly a product of x with any constant we can find as k into x, where k is any constant. We write constant as, then differentiate x with respect to x. This is one. So we have k into 1 which gives k. So if you have only product of any constant and x, then directly you can use derivative as a constant. This. Okay.
Constant.
Let us
Okay.
understand by
Yeah.
using a corresponding example for first formula. Example, if
But
we
if
need
it
to
is
differentiate.
only X, right?
Yeah, its
And
value
if
is
you
1.
have any exponential, then it will be different.
Okay. So here we
Hello.
are differentiating 5. So 5 is constant. So its derivative is 0. Got it? Because there
Okay.
is no change.
Yeah. Okay.
And next example, because second is of about only x, so it is in itself example of itself this. So let us do example for this. So let us differentiate 2x. 2 is constant, so write outside of this sign of derivative and write down as. So you know very well value of this with respect
Yeah.
to x of x is 1. So we can write directly this constant. For example, if we have, we need to do differentiation of 10x. So we can write direct 10 because
10.
differentiation of x is 1. Okay.
Yeah.
So now
But
let us
what if X
learn
has
the.
some powers?
Yes, yes. We learned further formulas. We have lots of formulas of that.
Okay, okay,
Now
okay.
we have that formula. If we need to differentiate having the power x and the power n, then write down power first and just subtract 1 from its power. Okay, this is the formula. For example,
Okay.
if we need to differentiate x to the power 7, so we need to write here 7 first and just subtract 1 from its power. So derivative of 7 to the power x is 7 into x to the power 6. You got it?
6. Okay.
Got
Yeah.
it?
Yeah, yeah.
Okay. So let us learn the next formula. That is differentiation of e to the power x will be the same e to the power x. Okay. And
Okay.
differentiation of log x for logarithmic function we have 1 upon x. And let us learn next trigonometrical formulas. Next seventh, differentiation of sin x we have cos x. And next, differentiation of cos x. We'll do example further by combining more than one function later. Some more difference or product later. So let us learn first formula, then we'll do examples. Okay?
Yeah, okay.
By taking more than one function together.
Yeah.
So differentiation of cos x is minus sin x, and the differentiation of sorry, ninth formula is d over dx of tan x is equal to sec square x, and d over dx of sec x, that is sec x into tan x. So we'll use them directly, okay, in questions, and this
Okay.
portion of that calculus based on these formulas. Because
Okay.
integration, you know very well, just reciprocal means just of that differentiation, reverse of differentiation. You know
Yeah.
very well integration. That is why we need to
No,
understand
no.
well.
Actually, that's what I'm saying. I forgot most of the basic topics itself. So I'm just kind of trying to remember, but it looks like new only.
Pardon?
You got it?
You know them?
No, no. No, no, I'm saying, so I have done my UG very long back. After that, there is no touch. And I
Okay.
forgot most of the max basic topics itself. I'm trying to remember it, but it
Okay,
looks
it's
new
okay.
also.
I'll make you remember. Okay, not a problem. You will have this
Yeah.
whiteboard saved in the class on teachment.
Okay.
You can see this
Okay.
saved whiteboard in study material section, and also you have this live recorded lecture in recording section. You can
Okay.
see further for revision. Okay,
Yeah. Okay.
so there is no need to write anything. You will have each and everything in your class. You can see.
Yeah. Okay.
Okay. So uh, next formula. Differentiation of cot x is equal to minus cosec square x, and differentiation of cosec x is minus cosec x into cot x. And we have one more formula here that I will do inverse trigonometrical function. If you have in your syllabus, we'll do later. These are the main formulas till this 13, okay? And
Okay.
and differentiation of a to the power x, a is any constant, is equal to a to the power x into log a. So these are basic formulas of differentiation. So let us do a few examples to understand these all formulas well. Shall we?
Yeah. Yeah. Yeah.
Okay. All right. For example, we have y is equal to x to the power 5 plus e to the power x plus sin x. And we need to find dy over dx. Means just derivative of y with respect to x. So let us find it. D
Yeah.
over dx of y is equal to take
5x
this
power
value of
4.
yeah, x to the power 5 plus d over dx of e to the power x plus d upon dx of sin
Sin
x.
x.
Now we'll use formulas of all of these. Okay.
Yeah.
So first is this power rule. So what will we do?
5x power 4.
Yes, exactly. So dy over dx is equal to 5 into x to the power 4. E to the power x, differentiation of d to the power x is e to the power
1.
x, same as.
Oh, okay.
And differentiation of sin x is cos x.
Cos x.
Okay, so this is the
Yeah.
answer.
Okay.
Let us do some more examples, including all of these formulas. Okay, let us do three,
Yeah.
four examples, including all of these formulas. So let us take here next example, and let us do on next page. So we have y is equal to 17 to the power x plus log x plus 10x, and we need to find derivative of this function, means dy over dx. So let
Okay.
us find it is equal to d over dx of 17 to the power x plus d over dx of log x plus d over dx of 10x. And 17 to the power x means just compare with this formula a to the power x. Here a is any constant, okay? So here instead of a we have 17. So
Yeah.
its formula is a to the power x into log a. It means
Yeah.
17 to the power x into
Power
log
x
17.
log 17. Yeah.
Yeah. So and differentiation of log x is 1 upon x, and
Okay.
differentiation of tan x is x square x. So this is required
Yeah.
dy over dx. You got it?
Yeah. Okay.
Okay, all right. So let us take next example. Y is equal to cot x plus cosec x plus sec x. Now we need to find derivative of y with respect to x in similar way. So d over dx of cot x plus d over dx of cosec x plus d
D
over
over
dx
dx
of
of sec
sec
x.
x. Now we can use the formula. So formula of cot x is minus
Okay.
cosec square x, and this is we have minus cosec x into cot x, and derivative of sec x is sec x into tan x. And we can take here minus sign also because we have here minus. So you can use
Yeah.
directly minus also, or can write in next step. Okay. Either you
Yeah.
can use in next step or you can use here directly minus sign. So
Okay.
this is the required answer. So now you got it.
Yeah.
Okay. So let us learn the next formula. You can say rule, product rule of the differentiation, and then quotient rule. Shall we do?
Okay. Yeah.
If we have y is a function of product of two functions, and we need to differentiate them as, then we use product rule. If y is equal to u into v, where u and v are function of x, then dy over dx is equal to first function, that is u, into derivative of second function, plus second function into derivative of first function. This is
Okay.
product.
No, I didn't get this part. Where u and v are function of x, what does it mean?
Pardon? This
No,
one?
yeah, u and v are function of x you mentioned, right? So, uh, I
Yes.
I didn't get that part.
And we can find a differentiation of product of these function by using this rule.
Okay.
Means we'll write first function as such, then multiply the
Okay.
derivative of second function, then write the second function as such, then differentiate the first function. You can understand well by
Okay.
using example also. Okay. For
Yeah, yeah.
example, if you have y is equal to x square into sine x, if you have, and we need to find its
Okay.
derivative or differentiation, we need to differentiate it. So we have first
Yeah.
function u and we have second function v. Now got it?
Okay. Yeah.
And now we need to find differentiation of y with respect to x. So we can do dy over dx, first function x
X
square,
square.
and into derivative of second function, plus second function into derivative of first function. Now you got it?
Yeah.
We are using this rule, product rule.
Yeah. Okay.
Okay.
Got it. Yeah. And what if has product of three functions?
So we need to means use twice also. Means I'm telling you by using next example. Okay, how can you use?
Yeah. Okay.
We use obviously product rule, but inside we will use one more, mean one more times. Okay,
Okay.
how will,
Yeah.
yeah. In next example, I'm telling you how can we use. If we have product of
Yeah.
two, three, four, how can we? Okay.
Okay.
So
Yeah.
now dy over dx is equal to x square, and derivative of sine x is cos x, plus sine x, right, as such. And now apply power rule here. That is 2x.
Two
Shall I
x.
write
Yeah.
direct? Okay.
Yeah.
So x square cos x plus 2x sine x. This is the required differentiation. Means
Okay.
derivative of x square, we have 2x.
Yeah.
Yeah. So in this way, we can differentiate the product of two functions. And now let us do for three, right?
Yeah.
Okay. Like if we have y is equal to x e to the power x into 10x. We have three. So
Yeah.
you can take in pair first. Either you can consider this one whole or even consider this one whole. Okay. You need to first take
Okay.
together two. Let
Okay.
us take
Okay.
them together as a first function like u, and take this second function as a v. So we are now using product rule. Then inside we are using also, inside it we'll use
Yeah.
also
Got it.
product rule. Yeah.
Got it. Yeah.
So let us find it. Dy over dx. Take first function as such, into derivative of second function plus second function into just differentiate the first function, that is x into e to the power x. Now we'll apply again product rule with on it. Okay.
Okay.
So in next step we'll use that. So x into e to the power x and derivative of tan x is x square x plus 10x will keep as such, but inside we are using here again product rule for product of these two functions. First function derivative of second function plus second function into derivative of first function. Are you getting this step?
1 minute. Tan X. Yeah, I
See,
got it. Yeah, I
yeah,
got it. I
because
got it.
we are differentiating here product of two functions. So
Product.
again, we
Yeah.
are
Okay.
applying here product rule.
Okay. Okay.
Okay. So in this way, we can find for product of three or more. So
Okay.
x into e to the power x into sec square x plus 10x into x and differentiation of e to the power x is e to the power x plus e to the power x and differentiation of x with respect to x is 1 only. So we can see here e to the power x everywhere common. X
Yeah.
into e to the power x into sec square x plus 10x into x into e to the power x plus e to the power x. So we can take common also
Okay.
from entire. So take common. So we have here x into sec square x. Just multiply 10x inside. So I write x 10x. Or you can take x plus 1 also, okay, directly if you don't want to multiply. Are you getting this step or not?
Yeah. Yeah. I got
See,
it.
if we
Yeah.
take e to the power x for both of them, then we can write it as x plus 1 into
Tan
10x.
X. Yeah.
This is the required answer. Got it?
Okay. Yeah.
Okay. So now let us learn the next rule, that is quotient rule. Shall we?
Yes. Yes. Yeah.
Okay. We use quotient rule when we have quotient form of the means two functions. Means y is a quotient. Y is in quotient form of two function like u and v. Okay, here u and v are the function of x. So dy over dx can be expressed as right on denominator, then differentiation of numerator minus numerator into differentiation of denominator over denominator square. This is quotient rule. You got it?
Okay. Yeah.
Okay. So now let us do one example related to this to understand it well. If we have like y is equal to like log x over sin x, we have quotient form of these two functions. Log x is u and sin x is v. Now we need to
Okay.
differentiate it. So just find the dy over dx. Write down denominator first, that is sin x, and differentiation of numerator, that is log x, according to formula, or you can say
Yeah.
rule. Minus denominator now, write down denominator into derivative of denominator and over denominator square, that is sin x. So now let us use the formulas. Sin x writes as such, and differentiation of log x is 1 upon x minus, write on here, log x, and differentiation of sin x is cos x. Are you getting this step?
Yeah.
And into sin square x. So we can write it. Let us simplify sin x over x minus log x into cos x. Or we can do one more thing, Sin square x is denominator of both term, So shall we take here, see, we can take here sin square here also by
Yeah.
splitting sin square x. And in next step, we can write in this way, dy over dx is equal to sin x over, we have x in denominator, and now we have sin square x also in denominator, minus log x into cos x over sin square x. And we can cancel this. It's 1 power, and this is 1 upon x. See, you can write like this answer also by taking x here in
Okay.
denominator in simple way. If sometime we need to prove it, okay, then
Okay.
we'll obviously simplify further.
Yeah, I got it.
And now cos x over sin x, you know very well, that is cot x. And 1 upon sin x, cosec x. Do you remember
Okay.
trigonometrical identities? So here we have
No,
sin
no.
square. So one time you can make this cos over sin cot x and take one another
Okay.
sin x as a cosec x. So here
Okay.
also we can use the same thing, 1 upon sine,
Yeah. Okay.
and that is
Okay.
cosec. So cosec x over x, and we can use here also log x into cot x into cosec x.
Cosec X.
So this is the required answer.
Okay.
Yeah, this is the maximum simplified term, means answer we have.
Yeah, got it.
So what do you want? Want some more topics today, or it is enough for demo? What do you say?
Yeah, I think this is fine. Looks fine. But
Okay, all
I'm
right.
only worrying this. You're saying my sound is not audible, right?
Now I can hear you properly.
Oh, okay, okay. Then it's fine.
In the beginning, I couldn't hear you, so now it is fine.
Yeah, okay then.
So you got
So,
everything, or want to ask anything which I need to repeat?
no, no, no doubts actually. I'm able to understand. Even though I forgot this formula, like,
I'll give you
uh,
notes also, okay? And you can see this
okay,
whiteboard in study materials section.
okay, okay.
Okay.
Yeah,
Yeah.
okay.
Uh,
And
when you see
so
your
one,
class
two
on
doubts.
engagement, yes, see, ask.
Yeah, yeah. So you said like for the entire this syllabus, you said 10K, right?
Yeah, for entire syllabus.
Okay, and again for individual class, like per hour, you said 500. So it's not matching. So that's why. So it is for entire syllabus. If I'm enrolling, it is 10K. You're saying
Okay, because sometime your voice lagging. So shall we discuss on call
WhatsApp?
about this? You are discussing with me. Shall we do this on call?
Yeah, yeah, fine. So that's why. Okay, I'll call you.